Hello everyone, welcome back to Deeksha Karnataka YouTube channel, and today in the top 30 physics series I am going to discuss about the chapter ray optics and optical instrument. It is a very important chapter. Up to 4 questions usually comes from this chapter every year. So without much delay, let's discuss with the questions from this chapter. So initially there will be some questions which are easy, some questions are difficult, some questions are moderate, as in line with the KCET question paper. Let's see. For a given pair of transparent media, the critical angle for which color is maximum? So we know that for a given pair of media, if we discuss about refractive index is basically 1 by sine theta c. What is theta c? Theta c is the critical angle, right? So basically refractive index is inversely proportional to sine of theta c. Again, refractive index is inversely proportional to wavelength lambda. Right, so from there we can say that enemy of enemy is my friend. So because both of them are inversely proportional, so we can say that sine theta c is directly proportional to lambda. So higher the lambda, higher will be the angle of theta c, because sine 0 is 0, and as you are going towards sine 90, the value of sine increases. So lambda sine theta c is proportional to lambda. So that means as lambda increases, that means the value of sine theta c is going higher and higher. That means the angle of critical angle will also increase. So out of all these, red light has highest wavelength, so critical angle for red will be the maximum value. Okay, so you have to remember this relation and this relation, right? Now next question. An equiconvex lens made of glass of refractive index 3/2 has a focal length f in air. It is completely immersed in water of refractive index 4/3. The percentage change in the focal length. So initially what was focal length? From lens maker's formula we know that 1 by f equals to n minus 1 into 1 by r1 minus 1 by r2. Okay, initially the focal length was f and the refractive index of the medium was 3/2. So minus 1 by r1 minus 1 by r2. Okay, so this value becomes 3/2 minus 1 is 1/2. So I will just use my board and I will write it as 1/2. This is 1 by f. Now if once you immerse it into liquid water, okay, what is the focal length? Say the focal length is 1 by f1. Suppose the focal length is 1 by f1, focal length is f dash. Then what will be the formula for that? Now to find the same formula, we have to adjust this value of n. How to do that? First we will write the refractive index of the glass, that is the medium of the lens. Next we will add the refractive index of the medium on which it is immersed, that is the glass, and everything else will remain same, 1 by r1 minus 1 by r2. Now what is this value? So this is basically nothing but 3/2 into so this is in division, it will reverse, so 3/4. So it will be minus 1, so it will be 9/8 minus 1, so it will be 1/8, right? So this value will be nothing but 1/8. So let me put it here. So if you just download the PDF, you might think, sir, how you arrive at that value? For that you have to check the video. So now if we do the division, this is equation 1, this is equation 2. So if we do the division, you will get f dash by f equals to 8/2. These things will cancel, so you'll get 4. So f dash is basically 4f. Right, so focal length increases 4 times. Now what is the percentage increase? Percentage increase is delta f is basically final value minus initial value, that is 3f, divided by f, okay, and into 100% is the percentage change. So it will be, the percentage change will be 300%, right? So it is a 300% increase. So option C is correct. Okay, so be careful. This is, even though this is a simple problem, you might think 400% increase. 400% is not increasing, it is only increasing by 300%, because increase or decrease means you have to find the difference, whereas times means only the how much times it is increased. So 4 times, 5 times is times, but whereas you have to find the percentage difference, you have to first find the difference, then divided by original value, then you can say 300% increase. Next question, a point object is moving at a constant speed of 1 meter per second along the principal axis of a convex lens of focal length 10 centimeter. The speed of the image is also 1 meter per second when the object is at a dash centimeter from the optical center of the lens. Now very interesting question. So image and object. So we have a convex lens, right? Convex lens. Object is moving with a speed of 1 meter per second, and the image is also moving at a speed of 1 meter per second, and that only happens when the object is located exactly at the center of curvature, because at the center of curvature object size is equals to image size. Okay, object's position is equals to image position magnitude wise. Only thing that is inverted, otherwise they are same. And by that logic we can also say that speed of image will be same as speed of object only when it is located at a distance of 2f. So focal length is given here as 10 centimeter, so object must be located at 20 centimeter, because only that place the speed of object and image can be same. Next, obviously if you are currently preparing for KCET 2025, or if you are someone who is preparing for COMET K 2025, then you must consider Abhyas KCET test series, which consists of 4 free and 31 paid test, full syllabus, chapter wise test. Okay, you will get detailed video solution and analysis, you will get chapter wise one shot revision video, chapter wise insight for last 5 years of KCET papers. Okay, and you can just download the test series from the given link in the description. Also, we have launched online KCET crash course for COMET K students. It will start very soon. Currently the test series is going on. You will get 12 mock test, full mock test. Okay, 12 mock test in KCET. In COMET K, 12 mock test means it's a full mock test consisting of physics, chemistry and maths. Okay, you will get complete syllabus coverage. Okay, 11th as well as 12th. 5 previous year questions, you will get live doubt clearing sessions, you will get class notes, recorded revision videos, and everything is only for 1099, right? So this is the COMET K crash course, and Abhyas KCET is test series, so that is why there is a price difference. So if you are someone who is preparing for COMET K, you have no idea what is COMET K, then definitely you should look into this crash course. Or if you are someone who is preparing for KCET and you want to practice questions, you want to learn from practicing, you want to check whether your solutions that you are solving is correct or not, then definitely Abhyas KCET is test series is for you. Now let's continue. For a point object, which of the following always produces virtual image in air? Okay, so let's see. Plano-convex lens. So there is a part of the plano-convex lens, means one part is plane, one part is convex. Now this is like a convex, but one part is plane, so this will still give you some real images, maybe not entirely, but there will be lot of real images by this. Okay, convex mirror always produces virtual images, so convex mirror will always give you virtual images. So correct answer is convex mirror. biconvex lens or convex lens obviously gives you real images. Concave mirror also gives you real and virtual images. So all these three, A, B, A, C and D, they will give you mostly real and some virtual images, whereas convex mirror will always give you virtual and only virtual image. So option B is correct. Now next, consider a glass slab which is silvered at one side and other side is transparent. Okay, so we have a glass slab, one side is silvered, other side is transparent. Given the refractive index of the glass slab to be 1.5, if a ray of light is incident at an angle of 45 degree on the transparent side, the deviation of the ray light from the initial path when it comes out of the slab is. So first let us understand what is the question is. Okay, we have a glass slab, okay, this side is, suppose we have this side is silvered. Okay, so a ray of light incident on the plane at an angle 45 degrees. Okay, and then it came here, it reflected and then it came out, right? Now this angle will also be 45 degrees. Now how, what is the angle of deviation? Angle of deviation means the angle it makes with the, so this is the original path of the ray. Okay, and the angle it makes with the original path is called angle of deviation. Right, so you have to find what is the angle of deviation. If the ray would have gone to the other side, then it would have been lateral shift but no deviation. Here because it is reflecting, the angle is basically angle of incident is equals to angle of reflection. So here you can also say that this is 45, this will be also 45. So how can I find the angle of deviation? Angle of deviation is this angle. So basically it is always remember 180 minus 2i for any kind of reflection. 180 minus 2i for any kind of reflection, because angle of incidence is 45 degrees, so it will be 2 into 45, so it will be 90 degrees. So 90 degree reflection is the answer. So correct answer is option B. Next question, focal length of a convex lens will be maximum for green light, red light, blue light, yellow light. Now again, what is the relationship? So from the lens maker's formula we know that focal length is directly proportional to n minus 1, or if we ignore this minus 1 for the time being, so focal length is directly proportional to wavelength, refractive index. Again, refractive index is inversely proportional to lambda. Right, so again friend of friend, enemy of enemy is my friend, so focal length is directly proportional to lambda. So higher the wavelength, higher is the focal length. Maximum focal length will be for obviously red light, and minimum focal length will be for blue light or violet light. Okay, now next question. A ray of light passes through an equilateral glass prism in such a manner that the angle of incidence is equal to angle of emergence, and each of these angle is equal to 3/4 of the angle of the prism. The angle of deviation is, so I is equals to E. Okay, angle of incidence is equals to angle of emergence. So what is this condition? This is the condition for minimum deviation. Okay, so this is the condition for minimum deviation, and this is actually 3/4 of A. It is given by 3/4 of the angle of the prism. Now this is a equilateral prism, right? That it is a equilateral glass prism. Equilateral glass prism means A equals to 60 degrees. So I equals to 3/4 into 60, that is 15, that is 45. Now what is angle of deviation? Angle of deviation is 2i minus A, because I is equals to E. So this is the angle of deviation. Angle of minimum deviation also same equation, right? Because I is equals to E. In case I is not equals to E, then you have to use the formula delta equals to I plus E minus A. This is normal general formula, but in case of minimum deviation, I is equals to E, so it becomes 2i. Okay, so this is basically delta M. even though we don't need that, but anyway. So 90 minus 60 equals to 30 degrees. So 30 degrees is the angle of deviation. So correct answer is option C. Next question. A convex lens of focal length L is placed somewhere in between an object and a screen. The distance between the object and the screen is x. If the numerical value of the magnification produced by the lens is m, then the focal length of the lens is. This is a very interesting question. I think few years back it came in KCET exam. So what is the question is, we have a lens, we have an object over here, and we have an image. Now this image is forming on the screen, so that is why we can say that the image is real image. Now the distance between the object and the screen is given by x. Distance between the object and the screen is given by x. Now the magnification is given by m. Now what is this distance? This distance is u and this is v. Right? This is u, this is v. Now what is the magnitude of magnification? Magnitude of magnification is basically m equals to v by u. Okay, we are not considering sign, we are only using the magnitude. That is why we are using this formula, or from there we can get that v equals to m into u. V equals to m into u. Now from this diagram what we can write? X equals to u plus v. Right, x equals to u plus v. So you just put the value over here, u plus m into u, or it will be u into 1 plus m. This is the value of x. Now what we will do, or this is we are not looking for value of x, we are looking for the value of u, right, u and v. So what we will do from here, we can say that u equals to x divided by m plus 1, right? This is equals to u into m plus 1. So u is equals to x into m plus 1, and what is the value of v? V will be equals to mx by m plus 1, right? M into u. So u we have calculated, so from there we can find v also. So basically what we are trying to do, we are trying to find the lens equation, okay, in terms of u, v, in terms of x only. Okay, now we will use the sign convention. Okay, v here is positive, so what is the value of v? Value of v is mx divided by m plus 1. What is the value of u? Value of u is minus x divided by m plus 1. Why minus? Because u is on this side. Now convex lens, focal length positive, so it will be 1 by f. Now let's find it out. So m plus 1 divided by mx minus m plus 1 divided by x equals to 1 by f. Now if you see that m plus 1 and divided by x is common, so m plus 1 divided by x goes common, so we get 1 by m, and this becomes positive, plus 1 equals to 1 by f. Negative, negative, positive, that's why this is positive. Okay, so m plus 1 divided by x into m plus 1 divided by m equals to f. So what do we get? We get m plus 1 whole square divided by mx equals to 1 by f. So from here we get f equals to mx divided by m plus 1 whole square. Okay, so f equals to mx by m plus 1 whole square, so it will be mx by m plus 1 whole square. Option B is correct in this case. This is one of the tricky question, but if you do the step-by-step method and if you know how to solve it, you can solve it. But this is one of the trickiest question, came from this chapter in previous year KCET exam. The power of an equiconcave lens is minus 4.5 D, and it is made up of material of refractive index 1.6. The radii of curvature of the lens is, okay, equiconcave. First of all, what is the meaning of equiconcave? equiconcave. So equiconcave means it looks like this. So if this radius is R1, this radius is R2, then R1 equals to R2 equals to R. This is called equiconcave. Plano-concave means one side is plane. Equi means both sides are same. Now what is the Lensmaker's equation? 1 by F equals to n minus 1, 1 by R1 minus 1 by R2. Okay, now power of the lens is given. Power of the lens is minus 4.5. So 1 by F is minus 4.5. Now remember that here all the distances are measured in meters. Okay, but if you want to convert it into centimeter, then what you have to do? You have to, here focal length is measured in meters. Okay, so 100 by F is when everything is measured in centimeters. So you have to multiply 100 in both sides. So you will get minus 450. 450 is the focal length when you convert it into centimeters. Okay, so we will use, because we are solving it for competitive exam, you need to have that idea and multiply diopters into 100 if you are using directly. Okay, so this is a very, very important trick. So 450, this will save a lot of time. Otherwise you have to find focal length F. Okay, 1 by F, then you have to multiply it with 100, you will get some value, then again you have to convert it, right? So this is a way to convert directly from focal length power to focal length. So power is basically 1 by F. Now this here focal length is in meters, right? How can you convert it into the centimeters? So if you convert it into centimeters, then you have to do 100 by F, that is minus 450. Okay, so 450, this one is same thing. Okay, this is also 1 by F, but here this is also 1 by F actually, but here it is in centimeter. Okay, how to do that? Basically what you have done, 1 by F in meters into 100 is centimeter equals to minus 4.5, or 1 by F in centimeter is equal to minus 450. Okay, just remember this. So basically you have to multiply the power with 100 to convert it into centimeter. If all the units were given in meters, then we would not have done this. We have to read the options as well. If the options was already in meters, we do not need to do it. We could have kept the same value. So minus 450 equals to 1.6 minus 1. Now 1 by R1 equals to 1 by R2. So you might think, sir, this will be 0. Actually no. R1 is on the left hand side, so it will be negative. Okay, and R2 is on the right hand side, so it will be positive, but both of them are R. So one of them is minus, one of them is plus. So this is minus in case of convex mirror, convex lens. This is plus, this is minus, this is plus. So it is always, you will get this 2 by R, either plus or minus. Okay, now because there is a negative sign, we want to cancel that, so that's why we know that this will be minus, so it will be always 2 by R. So 450 equals to 0.6 into 2 divided by R, or R equals to 0.6 into 2 divided by 450. Okay. The power of an equiconcave lens is minus 4.5D and is made of a material of refractive index 1.6. The radii of curvature of the lens is. So basically here we have a equiconcave lens like this, right? And equiconcave means the radius of curvature of both sides is same. So this side is minus R, this side is plus R. This is equals to R1, this is equals to R2. Right? What is the Lensmaker's formula? Lensmaker's formula is 1 by F equals to n minus 1, 1 by R1 minus 1 by R2. Now R1 and R2 are same, but R1 is negative, so it will be 1.6 minus 1 into 1 by negative R minus 1 by plus R So it will become 0.6 into 2 by r. There is a negative sign. Minus minus, minus will common. Now 1 by f. What is 1 by f? 1 by f is basically the power of the lens. Now power of the lens is given by minus 4.5. Now remember that here power, in this case the distances are in meters. Okay, if you are using the same formula, distances are in meters. So initially we will find the value of r in meters and then we will multiply 100 to convert it into centimeters. Okay, so r equals to minus 0.6 into 2 divided by minus 4.5. So minus minus cancels, this decimal cancels, so we get 3 2s are 6. Okay, 3 15s are 45, so it will be 4 by 15 meters. This is in meters. Now you have to convert it into centimeter. So it will be 400 by 15. Why 400? Because you have to multiply this in 100 to convert it into centimeters. So this is now centimeters. Now let's see, 3 5s are 15 and 5 8s are 40. So it is 80 by 3. 80 by 3 means what? 80 by 3. So it will be 80. 2 3s are 6. 20. 3 6 are 18. So 26. 26.6 centimeter minus. So if you are saying this one is minus, this one will be plus. So anyway, sign does not matter in this question, in my opinion, because one of them is positive, one of them is negative. But radii of curvature means both are same, and as you can see that this is minus 26.6 centimeter. So this will be the answer for this question. Okay. Now next question. If the refractive index from air to glass is 3 by 2 and that from air to water is 4 by 3, then the ratio of focal lengths of glass lens in water and in air. So we have solved a similar question. Let's see. So 1 by f in so we have to find the ratio first in water, second will be in air. So ratio of focal length in air. First we are finding air. Air is 3 by 2 minus 1 into 1 by r1 minus 1 by r2, which is equals to half 1 by r1 plus minus 1 by r2. Okay, now what about f water? F water is 3 by 2 divided by 3 by 4, right? 4 by 3, sorry. 3 by 2 divided by 4 by 3. Right? Relative refractive index. Relative refractive index means the medium's refractive index always comes in the division. Right? Minus 1, 1 by r1 minus 1 by r2. So here we get, this one will go up, 9 by 8 minus 1, same thing, which is 1 by 8, same thing. Now we are trying to find, first we will find water and then we will find air. So we will divide this equation with this equation. So 1 by f air divided 1 by f water is equals to 1 by 2 divided by 1 by 8, or it will be 8 by 2 equals to 4, or f water divided by f air equals to 4:1. So answer is 4:1. Okay, remember which one is first, water is first or air is first. Always in ratio related question the order is very, very important. So as you can see, 4:1 is also there, 1:4 is also there. So don't make the mistake, be careful which one is first. Next, in refraction light waves are bent on passing from one medium to the second medium, because the second medium the frequency is different, the speed is different, coefficient of elasticity is different, amplitude is smaller, the speed of light is different. Because of different speed of light, light bends by different amount on entering different medium, right? Next, two thin biconvex lens. So two thin biconvex lenses have focal lengths f1 and f2. So two biconvex lenses f1, f2. Okay, and the third biconcave lens has a focal length f3. Okay. Now, if two biconvex lenses are in contact, if these two are in contact, the power of the lens is P1. Power is P1. Okay. If first convex lens is in contact with the third lens, the total power is P2. So, first and third is P2, and the total power, if the second lens and the is contact with the third lens, if the second lens is in contact with the third lens, the power is P3. Now we have to find what is P1, what is P2, and what is P3, right? Now focal length of convex lens is always positive, focal length of concave lens is always negative. So let's solve it one by one. P1 is when both of the lenses are in contact, so it will be simply 1 by f1 plus 1 by f2. This is the formula, right? This is the formula for 1 by f equals to 1 by f1 plus 1 by f2. Two lenses in contact, right? So just need to add them. What you will get? Power gets added, right? So f1, f2, f1 plus f2, both are positive. P2 is when first lens is in contact with the third lens. Now third lens is concave lens, so it will be negative. So it will be f1, f3, f3 minus f1. Okay. P3 is 1 by f2 minus 1 by f3. Same reason. So f2, f3, f3 minus f2. So these are the three powers. Now let's check the option. So obviously this is not correct. Now we have to check which one of them is correct. In P1 both are positive, so if you just calculate the first power, you will get the correct answer, right? Because both of the focal lengths are positive, so in that case both the intermediate sign will be positive. So from there this sign you can say that okay, this is the correct answer, and you can check the other two options also, they are correct. So this is the correct answer. Okay, next question. The size of the image of an object which is at infinity as formed by a convex lens of focal length 30 cm is 2 cm. Concave lens of focal length 20 cm is placed between the convex lens and the image at a distance of 26 cm from the lens. The new size of the image is. So first, what is the size of the image of an object which is at infinity? So first the object was at infinity, okay, and you kept an convex lens, and you are getting an image. Where you will get the image? You will get the image at focus. You will get the image at focus because object is at infinity, so you will get a image at focus. So this is a image of size 2 cm. Okay, focal length is 30 cm. Focal length is 30 cm, right? If a concave lens of focal length 20 cm, now we are placing a concave lens of focal length 20 cm, where it is being placed at a distance 26 cm from the lens, from the first lens. Okay, so basically for this lens, this is the object distance. Okay, this is the object distance. What is object distance? Object distance is 30 minus 26, which is equals to 4 cm. 4 cm is the object distance. We have to find where the image will form. Okay, where the image will form, then we can find the size. So image distance in this case is plus 4. Remember, it is on the right hand side. So this is a virtual object, that is why the image distance is plus 4. What is V? We have to find. So 1 by V minus 1 by U, minus 1 by U equals to 1 by F. Now for a concave lens, the problem is basically for concave lens. Convex lens is only given at the beginning, where you have to find the starting position of the object. That's it. Okay, starting position is basically the 30 centimeter point because object is at infinity, so that is the only thing this lens is coming in. For other than that, it is basically based on the concave lens. So 1 by V equals to 1 by F plus 1 by U. Okay, or you get V equals to UF divided by U plus F. Right, this is the formula. Now let's put the value. U is positive over here, F is minus 20, and here it will be 4 minus 20, so it will be minus 20 into 4 divided by minus 16, right? 20 minus 4 minus 16, minus minus cancels, 4 4s are 6 or 4 5s are 20, so V is equals to 5. Okay, V is equals to 5. So what is the magnification? Magnification is always V by U. So V is 5, U is 4, so the magnification will be 1.25 times, right? 1/25 times. Now what is the size? Size will be into the original size, that is 2.5 centimeter. So it is actually enlarging the image, 2.5 centimeter, right? Now the refractive angle of a prism is A, and refractive index of the material of the prism is cot A by 2. The angle of minimum deviation is, so refractive index is basically sin A plus delta M by 2 divided by sin A by 2, right? This is the refractive index, formula for refractive index. Okay, now for this given material of the prism, it is given that the value is cot A by 2, right? What is the value of cot A by 2? Cot is nothing but cos A by 2 divided by sin A by 2, right? Cot means what? Cot means opposite of tan, so it will be cos A by 2. It's just a trigonometry problem, okay, not a physics problem. Now sin A by 2 cancels, so we get sin A plus delta M by 2 equals to cos A by 2. Now what is cos A by 2? Cos A by 2 can be written as sin, and this is A plus delta M by 2, the whole divided by 2. So it will be sin pi by 2 plus A by 2. We can write it like all sin tan cos. So it will be in the other coordinate, but still it is positive. So sin cancels, so you can take A plus delta M by 2 equals to pi by 2 plus A by 2, or this by 2 will cancel, so you get delta M equals to, sorry, this will not be a positive value, this will be negative. Pi minus A by 2 you have to take, right? So there will be only negative sign, other than that the problem is same. So it will be pi minus 2a. Pi minus 2a is the answer. Okay. So consider it's a equilateral triangle, then A is 60 degree. So 180 minus 120, that is, it will also be 60 degrees. Right. So in this case, this is a particular problem, so it is pi minus 2a is the answer. Pi means 180 degree, obviously. Next question. An object approaches a converging lens from the left side of the lens with a uniform speed of 5 meter per second and stops at the focus of the image. An object, let's understand the question once more. An object approaches a convergent lens from the left of the lens with a uniform speed of 5 meter per second and stops at the focus. So an object was coming towards the lens, okay, and it was after it reaches the focus, it stops immediately. Okay, now image moves away from the lens with a non-uniform acceleration, moves towards the lens with a non-uniform acceleration, moves away from the lens with an uniform speed of 5 meters per second, moves away from the lens with uniform acceleration. Now the problem is basically it's like a limit problem. Okay, you have solved questions in limit. So basically when the object is slowly going towards the focal length, when the object is slowly going towards the focal length, what is happening? The image is slowly going towards the infinity. Slowly going towards the infinity. Now suppose what was the speed? 5 meters per second. So 1 second before it was quite far away, 5 meters, in fact 5 meters away from the focus. Within 1 second it reaches the focal length. As soon as it reaches the focal length, the image which was hovering around very far away suddenly moved to infinity. Now infinity is obviously we cannot comprehend, it is bigger than whatever number we can imagine. So at this point of time it is obviously accelerating, and acceleration is obviously non-uniform. Okay, in fact the acceleration is infinite. Okay, so it moves away from the lens with an non-uniform acceleration. Okay, moves away from the lens with a non-uniform acceleration because it is going towards the infinity. So when the object is approaching the focal length, the image is moving away from the lens, right? Because it is going towards the infinity. So that is why it is basically non-uniform and moving away from the lens. Next question. The following figure shows a beam of light converging at a point P. When a concave lens of focal length 16 cm is introduced, the path of the beam at a place shown by the dotted line such that OP becomes the axis of the lens, the beam converges at a distance x from the lens. The value of x will be equals to. So here, as you can see in the figure, okay, this distance is 12 centimeter. Okay, so basically this is U. This is U for the concave lens. Okay, now concave lens focal length is 16 centimeters. So as I said, here U is positive because the object is on the right hand side. If it is a virtual image, obviously virtual object. So what is the U? U is 12 centimeter, and we have to find what is V. F is minus 16 centimeter. Okay, now if you remember the formula we have derived, it is basically UF by U plus F. You have to apply the sign convention, obviously. Okay. So U is 12. Now remember that whatever the question is given, it is basically the object distance, image distance. Okay, so don't get confused about x, y, z. Okay, they might try to confuse you always, because the problem is very simple. Only sign convention and this only sign convention is something that you have to be care of. And this, in this question, it is basically 48 centimeter. So correct answer is option B. Okay, this formula, if you just practice it 2-3 times, you will be able to remember. If you don't remember, 1 by V minus 1 by U is equal to 1 by F, anyway you can use. Okay, so now let's move on to the next question. Question number 16. A certain prism is found to produce a minimum deviation of 38 degrees, right? And also it is mentioned that it produces a deviation of 44 degrees when the angle of incidence is either 42 or 62. What is the angle of incidence when it is undergoing minimum deviation? Now for the angle of minimum deviation, we know that delta M is basically 2I minus A. Now delta M is given 38 degrees. okay, and we are trying to find I. So if we can somehow find this value A, we can find what is the value of I, right? For that, it is given that the angle of deviation is 48 degrees for angle of incidence either 42 or 62. That means we know that angle of incidence and angle of emergence, they come in pair. So I is 42 means E is 62 degrees. So what is the use of that? We will use that to calculate the value A. This A we will use using the second information, delta equals to I plus E minus A, right? So delta is 44 degrees for I 42 and E 62 minus A. So A is basically 104 minus 44. So A is 60 degrees, okay? So A is a equilateral prism, obviously. So from here we will calculate the value of angle of incidence. So 2y equals to 38 plus A, that is 38 plus 60, that is 98. So if 2i is 98, then I will be 98 by 2, that is 49. So I is 49. Option A is correct. So first stage to calculate A, second stage is calculate angle of incidence. Now next question. A point object is moving uniformly towards the pole of a concave mirror. So a point object is slowly moving towards the pole of a concave mirror. This is called pole. Obviously we know that. Focal length 25 centimeter along its axis as shown in the figure. The speed of the object is 1 meter per second, okay? At t equals to 0, the distance of the object from the mirror is 50 centimeter. Okay, so at the beginning it is 50 centimeter, that is the object is exactly at what distance? U equals to 2f, or object is exactly at the radius of curvature, center of curvature, sorry. So object is located exactly at the center of curvature. The average velocity of the image formed by the mirror between the time t is equal to 0 and t is equal to 0.5 second is. So basically at t is equal to 0, object is here, the image will also be here, right? So at this point of time the image is also moving with the same speed as object. But anyway, we are trying to find the average velocity. To find the average velocity, we have to find the total displacement by the image. So object is moving with the velocity 1 meter per second. After t equals to 0.5 second, what is the location of the object? First we have to find that. So speed is 1 meter per second, and after t is equal to 0.25, the displacement s is basically ut, which is equals to 1 into 0.25, that is 0.25 meter or 25 centimeter. So the object moved by a distance 25 centimeter towards the pole. So if the object moved by 25 centimeter, where the object is located now? Object is located here. What is the distance? The distance is 50 minus 25, that is 25. That is, the object is exactly located at focus. So the object is exactly located at focus. So if the object is located exactly at focus, where the image will form? Image will form in the infinity, right? For object located at focus, image formed at infinity. So infinity means image which was initially at 2f 50 centimeter, suddenly after 0.25 second it suddenly moved to infinity. So what is the displacement of the image? So image starting from 50, it moved to infinity. That means the displacement is obviously infinity. Infinity minus 50 is infinity. So what is the average speed of the image? So average speed of the image must be also infinity, because infinity divided by anything is also infinity. So average speed of the object, average speed of the image is infinity. Okay, very interesting question. Because the object moved from 2f to f, the image moved from 2f to infinity. So the speed, average speed of the image will be infinity. Okay. Next question. An object is placed at a distance of 20 centimeter from the pole of a concave mirror of focal length 10 centimeter. The distance of the image formed. Very, very interesting question. Only thing that you have to consider is about the sign of the thing. So we know that concave mirror forms real image. So object is located at 20 centimeter. 20 centimeter means what? 20 centimeter focal length is 10 centimeter, right? Focal length is 10 centimeter given here. So basically again the distance is 2f. So distance 2f means image will be forming over here exactly at 2f, and because everything is on the left hand side of the mirror, so basically this means the v will be minus 20 centimeter. Okay, v will be minus 20 centimeter because it is on the negative x-axis, right? So it will be minus 20 centimeter. Next question. A candle placed 25 centimeter from a lens forms an image on the screen placed 75 centimeter on the other side of the lens. The focal length and the type of the lens should be. So first, candle placed 25 centimeter on a lens forms an image on the screen. So screen means it's definitely a convex lens. It cannot be a concave lens. Concave lens cannot produce images on the screen. It only produces virtual images which does not require any screen, but a convex mirror obviously produces image in the screen. So here U is basically given by, and also U is given by 25 centimeter. Generally U is negative because U is on the left hand side, and the image is 75 on the other side, so definitely image is positive. You are trying to find what is the focal length. So focal length is 1 by f equals to 1 by v minus 1 by u, that is 1 by 75 minus 25. Now this minus and this minus cancel, so it will become positive. So 75 and 25 LCM is 75. 1 plus 3, so it will be 4 by 75, or f equals to 75 divided by 4, which will be equals to 18 point something, right? Less than 20. So answer will be plus 18.75, and it's a convex lens. Okay, answer will be it is a convex lens and it will be 18.75. Next question. During the scattering of light, the amount of scattering is inversely proportional to dash wavelength of light. Now scattering angle is inversely proportional to lambda to the power 4. Okay, this part is partly deleted portion, so anyway you can not expect this question, so we have solved it anyway. This is the question. A linear object of height 10 centimeter is kept in front of a concave mirror of radius of curvature 15 centimeter. So it's a concave mirror, radius of curvature is 15, that means focal length is half of that, at a distance of 10 centimeter. Okay, so object height 10 centimeter, it is placed at a distance 10 centimeter, the image formed is magnified. Oh, okay, so we don't need to solve the question. So just concave mirror, radius of curvature is 15, that means the focus will be at 7.5 and the object is placed at 10 centimeter. So object placed at 10 centimeter means where the image will be formed. So image will be forming behind 2f, okay, and it will be enlarged. Okay, as it is approaching the focal length, image is slowly going away from the 2f, right? So image will be inverted and it will be magnified, right? It will be magnified and inverted. So option B is correct. Real images are always inverted, and in this case image is magnified. Okay, if the image is beyond 2f, that the object distance is 20 centimeter for example, then it will be a diminished image. Okay, and obviously it will be inverted. Next question. A plain glass plate is placed over a various colored letters, violet, green, yellow, red. The letters which appears to be raised more it is. Okay, so here we have different colors, so red, violet, green, yellow. Okay, so these are the colors that dots are here, and who will raise the most? Suppose this is the thing, so it will raise by some amount. So we know that, so this is the apparent height. Suppose this is the apparent initial height u and the apparent height is v. Okay, so we know that u by v is basically the refractive index. U divided by v. U is the distance. Now this distance is same for everything. U is same for all the letters. Okay, but v will be different based on the color of the letters, right? So u by v is refractive index, and refractive index basically inversely proportional to wavelength lambda, right? So the height, okay, the height from the top, remember that height from the top will be more for higher wavelength. Okay, so red light, so now raising, what is raising? Raising means how much it raised from its initial position. So raising is basically difference in v minus u. Now u is constant, okay, v is more for red and very small for violet. So violet will be very, very small because it has the smallest wavelength. So the rising will happen more for violet. So violet will rise the most and red will rise the least, okay, because it has a higher wavelength. That means its refractive index is less. So less refractive index means less rise, higher refractive index means high rise. So the rising will happen the most for violet, right? Okay, so very careful, very interesting and easy question, but still you have to be very, very careful about this relationship. Next question, a ray of light passes through 4 transparent medium N1, N2, N3. So this is A, this medium is A, B, C, D, and this is E. Okay, so it says that with refractive indices N1, N2, N3 and N4 as shown, the surface of all media are parallel. Okay, so all the mediums are parallel to each other. Okay, ray DE, the ray DE is parallel to the incident ray AB. So basically it says that the ray DE is parallel to the incident ray AB. That means these two rays are parallel to each other. Okay, now these two rays are parallel to each other means definitely when two rays are parallel to each other, if the refractive index of this medium is equals to refractive index of this medium. Okay, so imagine that there is a glass slab, okay, and the ray of light is passing through it. So after it emerges out of the glass slab, the emergent ray and the incident ray, they are parallel when both side is air. Now in between, you does not matter how many mediums you keep, 1, 2, 3, 4, 5, 6, 9, 8, 10, 11, how many mediums you keep does not matter, as long as the initial medium and the final medium are same, the incident ray and the emergent ray will always be parallel to each other. Okay, so if they are parallel, that means N1 must be equals to N4. So N1 must be equals to N4. Option A is correct. Next question, focal length of a convex lens is 20 centimeter and its refractive index is 1.5. Ri means refractive index. Okay, it produces an erect enlarged image if the distance of the object from the lens is. So focal length is 20 centimeter. Now it is producing enlarged and erect. Enlarged and erect means the distance must be less than focal length. Okay, if it is a convex lens, okay, if the distance is less than focal length, this is focal length, then the final image is virtual, erect and enlarged, right? You remember that, right? So that was the case. Okay, slightly I draw it slightly wrong anyway. So basically that means that whenever the object distance is less than that of the focal length, okay, image will be always virtual, erect and enlarged. So the image distance always has to be less than 20 centimeter. Does not matter about the refractive index, okay, unless and until you are talking about any external medium. So external medium here is air, so this is not important for this question. So obviously C should be equals to 15 centimeter. Okay, A ray of light suffers a minimum deviation when the incident on a equilateral prism of refractive index √2. The angle of incidence is. So obviously we know that refractive index is equals to sine A plus delta m by 2 divided by sine A by 2. Now equilateral prism means A is equals to 60 degrees. Okay, equilateral prism same as equilateral triangle, only 3-dimensional, so angle is 60 degrees. So and this value is given as √2. Okay, now we'll put the value and we'll try to find the angle delta m. Sine A plus delta m by 2 divided by sine A by 2 means what? Sine A by 2 is sine obviously sine 30. Sine 30 means what? Sine 30 means half, right? So I'm just trying to do it as quickly as possible without wasting too much time. So that is equals to √2. So sine A plus delta m by 2 is basically equals to √2 into half. This entire thing will be cross multiplied in this, right? So here you will get √2, so you will get 1 by √2. Now what is 1 by √2? 1 by √2 is sine 45 degrees. So both sides sine, if you take inverse of both sides, you get A is now you will use the value of A is 60 degrees. So 60 degrees plus delta m by 2 equals to 45, or delta m equals to 90 minus 60 equals to 30. Okay, cross multiply 2 into 45 90, and this will come to other side, so minus 60 30 degrees. So delta m we have calculated. Now what is delta m? Delta m is 2i minus a, right? So 2i is basically 30 plus 60, that is 90. So I equals to 90 by 2, that is 45 degrees. So I is nothing but 45 degrees. Correct answer is option B. Okay, super simple easy question. Next question, calculate the focal length of a reading glass of a person if his distance of distinct vision is 75 centimeters. So you have to find the focal length of a glass of a person if its distance of distinct vision. So distance of distinct vision normal for a normal person is 25 centimeter. But the object for that particular person, the distinct vision distance is shifted to 75 centimeter. So U is EU is 25, and the person cannot see anything as close as this, so the image for this should be forming for the person at 75 centimeter, so that the person can still see that object. Okay, so it will be 1 by V minus 1 by U equals to 1 by F. Okay, so basically what is happening here, let us understand. This is you have learned about it in your class 10th, okay, in the human eye chapter, right? So this is the object. Okay, so this object was initially at 25 centimeter. So that is how we call it a normal, and after refraction to refracting through this, okay, it is going such a way that it is original image is forming at some distance which is 75 centimeter distant. Okay, so both are negative, so minus V minus U, so 1 by minus 75 plus 1 by 25. Okay, so you have to understand everything is happening on the left hand side, that is why the signs you have taken like this. So it will be 75 is LCM, minus 1 plus 3 equals to 1 by F, or 2 by 75 is equals to 1 by F, or F is equals to 75 divided by 2, that is 36.5 centimeter. Sorry, 37.5 centimeter. 37.5 centimeter. So correct answer is option A. Okay. Next question. A person wants a real image of its own 3 times enlarged. Where should he stand in front of a concave mirror of radius of curvature 30 centimeter? So person, first of all, it's a real image. Okay, so object distance must be more than that of the focal length. Okay, focal length is not given, but radius of curvature is given 30 centimeter. So radius of curvature 30 centimeter means focal length is 15 centimeter. Okay, we want 3 times enlarged image. Okay, so m is basically 3, and that is equals to v by u. Okay, enlarged 3 times, right? So v must be equals to 3u, right? V must be equals to 3u, right? So what is the mirror equation? 1 by v plus 1 by u equals to 1 by f. Now it is a concave mirror, so everything will be negative. Object distance, image distance, focal length, right? Because everything is real image, everything is happening on the left hand side, so everything is negative and negative sign will be cancelled, so the equation will remain as it is. Now what is v? V is 3u, 3 times enlarged, right? U is obviously u, and focal length is 1 by 15, right? So it will be 3u is LCM, 1 plus 3 equals to 1 by 15, or 3u by 4 equals to 15, or u equals to 15 into 4 divided by 3, 3 5s are 15, so it will be 20 centimeter. So the person should stand at a distance 20 centimeter from the mirror. Okay. Next question. If epsilon naught and mu naught are the permittivity and permeability of free space, and epsilon and mu are the corresponding quantities for a medium, then the refractive index of the medium is. Very interesting question. So we know that speed of light in a medium is given by c equals to square root of epsilon naught by mu naught, right? Similarly, speed of light in another medium is basically given by epsilon by mu. If epsilon naught and mu naught are the permittivity and permeability of free space, and epsilon and mu are the corresponding quantities for a medium, then the refractive index of the medium is. Now we know that speed of light in vacuum is given by 1 by square root of epsilon naught mu naught, right? Similarly, speed of light in another medium, any medium, is given by square root of epsilon into mu, right? Now what is refractive index? Refractive index is nothing but speed of light in vacuum divided by speed of light in that particular medium, right? So this is the formula, don't forget, don't confuse. Okay, so what we have to do, we have to divide it 1 by mu naught epsilon naught divided by 1 by mu into epsilon. So mu into epsilon will go up, okay, because it is in division, and mu naught by epsilon naught will stay in that here, right? So it is basically mu epsilon divided by mu naught epsilon naught. So this is the formula for refractive index. Easy. Next question, 29. An object is placed at 20 centimeter in front of a concave mirror, produces 3 times magnified real image. What is the focal length of the concave mirror? So object placed at 20 centimeter, so u is 20 centimeter, v is 3 times u because it's enlarged 3 times. So enlarged 3 times means always remember v equals to m into u. Okay, this is the easiest thing that to remember, so that you can solve it quickly. So v is 60 centimeter. Now concave mirror, everything is negative including focal length, so all the negative sign will be cancelled. So as it is, you just need to write 1 by v plus 1 by u equals to 1 by f. Now I write this equation like this so that I don't have to remember lens or mirror, everything is same, right? So 60, only the sign is different, plus 1 by 20 equals to 1 by f okay, or F equals to 20 into 60 divided by 20 plus 60. Okay, so it will be 20 into 60 divided by 80. So 80 means 0, 0 cancels, 4 15 is 60. So the focal length of the concave mirror is 15 centimeter. Now next question, statement 1. If a glass prism is immersed in water, its angle of minimum deviation is increases. Okay, statement 2. Angle of minimum deviation of a prism is increases with the increase in the refractive index of the prism. Now let's check the statements one by one. First of all, we know that n is equal to sine a plus delta m by 2 into sine a by 2. Now sine a by 2 is constant for a given prism, right? Sine a by 2 is the constant for a given prism. Now this n is refractive index. Now if you immerse the prism into the water, what happens is that the refractive index n will be, so refractive index suppose of the glass divided by refractive index of the water, Ng divided by n water. Now what happens is that when you immerse it into the water, the refractive index of the glass with respect to water, which is this value, decreases. So let us take the value of glass. Glass generally 3 by 2 and water is 4 by 3. So 3 by 2 means initially this was the value was 1.5. Value was 1.5. 3 by 2 is 1.5. Now once you immerse this into the liquid, it becomes 9 by 8. 9 by 8 means 1.125. Okay, so the refractive index basically decreases. Now what happens if refractive index decreases? Let us understand that as well. So first of all, refractive index decreases once you immerse it into a liquid of water or liquid, any liquid. Okay, now let us understand what happens to the angle of deviation. So sine a plus delta m by 2 is basically equals to n into sine a by 2. Now as I said, sine a by 2 is constant. So this angle is basically directly proportional to refractive index, right? So in other words, I can say that a plus delta m by 2 is directly proportional to n. There is sine inverse involved, but I am not considering that. So delta m is basically directly proportional to n. So higher the refractive index of the medium, higher is the angle of deviation. So second statement is correct. Okay, so angle of minimum deviation for a prism increases with the increase in the refractive index of the prism. So second statement is correct. Now what about the first statement? First statement is exactly opposite of the second statement. Why? Because if you immerse the prism into water, its refractive index decreases. Refractive index decreases means the refractive index decreases, I already explained. So the new refractive index of glass with respect to water is Ng by Nw, right? So which is less than normal Ng. You are dividing by a number, so definitely it will be less than Ng. So as you are immersing it into the water, its refractive index decreases, and as the refractive index decreases, its minimum deviation will decrease. So minimum deviation will decrease, not increase. So statement 2 is correct and statement 1 is wrong. So statement 1 is wrong, statement 2 is correct. So option D is correct in this question. So be careful, statement related questions. So if you see any statement related questions, be careful. Also, if you have not yet subscribed to our channel, then don't forget to subscribe to our channel. Also, if you want to practice for your KCET 2025 exam, then definitely you should try Abhyas KCET test series. The link is given in the description. I'll be back with a new chapter tomorrow. Till then, bye.